Hello, welcome to another cloud computing class tutorial. Today we are going to learn about Spark. We will run a couple of Spark jobs and we'll deploy Spark using Docker. Right, so as usual, I will start by creating a new virtual machine from scratch. I will set up Docker and I will start doing my stuff there. Right, so let's call this VM Spark VM. I will just have to select here an 8 GB memory of instance. I will change my boot disk to Ubuntu, and as usual, sorry, not Ubuntu Pro, Ubuntu, and my VM, it should be 50 GB of storage at this moment. Allow the traffic, create, and that should be fine. Okay, so I will just go here and create a new VM. So in this VM, we'll follow the usual stuff. The steps are install Docker, then set up our Spark cluster, and then run our jobs on top of the Spark cluster. We will have two examples. One will be with a master and one worker, and the second example where I will add two workers in my queue. Right, you can see my Spark VM is ready. I will click on SSH. I will open my window and I will bring my tutorial next to me as usual. So I will follow the tutorial and I will run my commands. So let's start by updating our environment when my VM is ready. And then, as you can see here, I will start installing Docker. If you have a Docker from a previous tutorial, make sure you remove all your containers before you proceed. So first, let's update. As usual, let's install Docker. And then we should be able to start playing around with Spark, alright? So first let's install Docker, just press yes here and press enter. And now I will go and add my usual Docker user. I will add my user in the sudo group, and I will also allow user to run commands without the sudo keyword. Alright, so when this is ready, I should be able to continue. Alright, it will take a minute. Okay, it's ready. Let's add a new user as usual. And now what I will do is I will continue here. I will add my user to the sudo group, and also I will allow my user to run sudo commands without the sudo keyword. And finally, I can say now, okay, let's switch to the Docker user, and I should be also redirected to the home Docker user directory. And that should be fine. Okay, these are the usual stuff we do every time we have to run a tutorial. So by now we should be able to install Docker with closed eyes, let's say like that. Alright, so the first thing to do, it will be to pull a Docker image for Spark 2.4.1. This is the one that we will use for this tutorial. Okay, so while we pull this image, you can see here that I need to open ports 8080, 8081, and 8082 for this tutorial. Okay, so this means that I have to go back to my TCP, go to firewall. Okay, let's find the firewall, okay, there you go. And I will need to create a new rule. So I have my new rules. I have old rules from before, but for this tutorial again I will create a new rule, Spark rules, and I will go here and I will say open this for all the instances again. After the end of this tutorial, go back and delete it, obviously. Source IP ranges are 0000, alright, as usual, and the TCP ports are 8080, 8081, and 8082. Alright, that should be fine. Okay, let's create this. Okay, so the rules are created. I will go back to my tutorial and bring back my my terminal here. I have my images, so I should be ready to go. So Docker images, and I can see here this particular image that I pull from Docker. Now the next step for me, it will be to export your external IP. So we will export the external IP in this variable that's called external IP with underscore. So every time we need to configure our scripts to use the external IP, you don't really have to go back and copy and paste. So it's like I create here a variable for this bus, so I can reuse it again and again and again. This external IP here will always represent the IP that I will give now. So if I go back to my GCP, I go back to my compute engine, and if I click here, I should just redirect it and just find the external IP. That's the one. Okay, just copy this, go back to the terminal, and assign this IP to the variable called external IP. Just press enter. Okay, so I have the external IP ready. I will clone this repo because I have everything here, so you don't really need to create it yourself. Just clone this repo, enter in this Spark tutorial. All right, you can clear your screen here. You can do an ls to see what we have. We have a couple of examples of Python, and we have two Docker Compose files. One is called one worker, the other is called extra worker. All right, let's see how we'll work with this. Now, I will start with the first one, that is the Docker Compose one worker. All right, so what I will do, I will copy this and I will rename this Docker Compose. If you remember, we need this Docker Compose file. Okay, every time we need to create a Docker Compose command, we need the Docker Compose file. What I did, I just renamed this to have it as a reference here, and we can actually copy the Docker Compose. We update it whenever we need. Just press enter here. You can see I have my Docker Compose file here now. Okay, so what I can do, I can cut this Docker Compose file, and I can see here what I have. I can also explore my file here. I have a master, as you can see here. This is the image, this is the command that I will run for the master. These are the ports, the mapping of the ports, and I have one worker, and this actually uses the same image, and this worker actually will connect to the master and create a cluster of a master and a one worker. All right, eventually I can have as many workers as I want. Now, literally what I have to do is I have to run the compose file, and this will set up my Docker cluster of Spark. But in practice, what I need to do first is to install the Docker Compose, because I need to install this explicitly. So just run this command and install the Docker Compose. Type yes here, and it should be fine. This command here, the Docker Compose app, it will actually create my cluster. Okay, let's run it when this is ready. So let me clear my screen and let's go. So this will create one master and one worker. You can see here it says done because it's actually, this is completed now. All right. So if I go to my URL here, back to my VM, copy this and open a new window here and go to port 8080, you should be able to see your Spark cluster here. Okay. You have one worker. You didn't run any applications yet, so everything is fine. Okay. But eventually I can access my master. Right now, I map this port number to 8080 in my Docker Compose configuration, so don't worry about the ports for the moment. Just follow the ports that we have in the tutorial. Okay, let me go back to my VM here. Let me bring my tutorial and actually my terminal here. So my cluster is ready. Okay, let's first start with this count.py file. Okay, we can explore it a little bit together, but if you follow the comments here, you will see that what I do, I'll create a text called words. I create a new word count application called word count. I call this configuration. I set up this Spark context in my configuration. I split the words called sequence, and this sequence I parallelize it in my cluster. And then I run this word count application on Spark that actually initialize every word with one, and then adds this, accumulates these ones together in order to count how many times each word appear in my text. All right, I stop the counts and I print the results. So essentially, I should see my results on screen at some point. That's the count.py, and I can see here that I should have a count.py. Yes, I have it here. All right, so it should be there ready for me to try it. All right, the next thing to do is to export the container ID. As I export the here, somewhere here, the IP of my VM, I call it external IP. I will create a similar variable in bus. All right, I will call it container ID in this case. And this will be the container ID, the ID of my container. So every time I need to use the container ID, I don't really need to go extract, copy and paste this. I just have to use the variable name container ID. It makes sense, right? So for example, I can go here and say, let me see the container ID. So if I run part of this command, I should be able to see the container ID. So I will say, you know, that the container ID equals to this string now. All right. So this command here will actually save the container ID this number here to this container ID variable. And I can use it again and again. For example, you can see here, I can start now running my code using this container ID. In this case, in here, what I do, I just copy this count in my temp directory inside the container. Okay, so literally I need to move my file inside the Docker container. Essentially, it will be in this file system of Spark, so we can actually have it there and run it. Okay, let's go and give it a go. So command 23, what it does, it executes this count.py file that is inside the TMP folder. It actually submits this as a Spark job, and you can see here, this is the address of the master that you need to submit it, alright? Just copy and paste the whole thing here, as you can see it from the tutorial, and press enter. Now, this will start a new Spark task in the master, and the master will talk with the worker in order to run the application. There are some configurations here happening. You can see the communication between the nodes, and at some point you might see this output, right? This is the idea of word counting, right? We were able to run our word count on Spark using Python in our case. Now, there are a couple of things here that you might need to search a little bit more. For example, the use of lambda functions in Python. You can follow a tutorial about this. The reduce by idea, that's similar to the reduce in MapReduce. The use of add, as you can see here, this is what we call an operator in order to sum up my value. So I don't really need to create an add function here and always accumulate. I can use this add operator directly from Python. All right, so a couple of things that to make my life easier, I just use it ready. So you can actually go and check a little bit more about these things. All right, so my first task here ran successfully. If I go back to my here to my graphical user interface of Spark, I can just refresh my website. I will see that I have one application that actually submitted and finished. It took 7 seconds to complete, and this is the memory per executor, and that's the number of cores that actually used, etc. Okay, so you can click here, you can see here more information about the task. Okay, if you can go back, right, I can see also information about the standard output here. Well, actually here, if I have any errors, I can see the log file. Okay, so I can play around a little bit, explore a little bit more about these things. Right, so that's my first app that I ran successfully. Now let's go back to my terminal. All right, not this one, I think it should be here. What I will do now, I will add a new extra worker, okay, a second worker into my cluster. I don't really need to take my cluster down and build a new cluster. What I have to do is dynamically add a new worker to my cluster. All right. The code for this is more or less the same as before. As you can see here, the new YAML file that is called Docker Compose Extra Worker. The only thing extra here is that instead of one worker, I have a second worker. I just copy all this and paste it here. I made some simple changes. For example, this port now it will be 8082. Before it was 8081. All right. So every time I add a worker, I need a new port for the new worker. Other than this, the setup is the same image, the same command, the same master. The master is at 7077, right? So that's the master that I have here. And the same configuration in my case. If you want, you can give more cores, more gigabyte of memory, all right? And obviously you can really change your port, all right? Now, what I will do is I will go back to my tutorial here, to my terminal, clear my screen. I can see here this Docker Compose Extra Worker, right? So I can literally copy this Docker Compose Extra Worker, all right? And I can call it again Docker Compose, all right? This will actually override the Docker Compose file. With one worker now we'll have 2 workers, all right? Just copy this and cut this Docker Compose YAML to see how it looks like. You should have 2 workers. Okay, I can see I have worker 1, 8081, worker 2, 8082. Perfect. Okay, so I have a new worker in my compose. Let's build it. So run this command. Eventually, we should be able to start worker 1 and worker 2. Okay, it says worker 1 is up to date. That's fine. It's running perfectly. Worker 2 is done now. So if I go back to my interface, refresh this, I have now 2 workers. All right, 8081, 8082. I can start adding workers in my cluster, and I can start parallelizing tasks now to multiple workers. I don't have just one, I have 2. eventually what I need is to have a space for my workers, right? My workers accommodate the space, like for example, let's say 2 GB of RAM. So I need a very good size virtual machine. Okay, so what I can do now? Well, I will try to run the example one. There is another example here. We do a couple of things here. For example, we create a function called positive to check if a number is positive. A function, we call it even, to check if a number is even. If in the case we return the number. And then we will do here the lazy evaluation, as we will talk about this in the class with an example, where we'll go through some filtering in order to filter numbers that need to be positive and even in order to save the numbers, let's say, or print the numbers. So in our case, we will run this for some numbers between -10 to 10. So I want to extract only the positive and even numbers belong in this kind of set, right? -10 to 10. Alright, so to run the example one, well, I have to do the same steps as before. I just have to copy this to my container. Again, I don't really need to find out what is the container ID. I just save it in this variable, so it's quite helpful. Okay, just do it there. And then execute the command. In this case, I have it just in one line. So I have to just take it and execute it. Alright, press enter. You can see I'm running the example one, exactly the same thing. Just submit example1.py into my master node. The master node will take care of the rest. Now, essentially here, we will be able to see these numbers that are greater than 0, okay, and they are actually even, all right? So I don't know if I print here, I print the count, so somewhere here I should see it, right? The Stelios count says it's 4, okay? So I count how many numbers are greater than 0 and even between -10 and 10, these are 4, right? But I did that in parallel in my cluster. I can go back to my interface here, refresh the website. I should be able to see a second job. All right, this is 4 cores. This means I used 2 different data nodes in my case. Okay, the workers actually. All right, that's good. I was able to complete 2 tasks. All right, let me go back to my tutorial. A couple of things here again is the idea of creating a parallel application. We filter with positive numbers. That's my first transformation. The second transformation, we filter with even numbers. Again, we'll discuss about transformations in class, and during the class also we'll go through this code and ask any questions you might have. Alright, let's continue. And now we will try to run a MapReduce similar algorithm to the Monte Carlo idea, right? We discussed about Monte Carlo last week. It's the idea of creating an algorithm to calculate the value of pi. And now today we'll run it on Spark, right? So just let me go here a bit and just clear my screen. Okay, so I don't need any more this one. A couple of things here. What I do, I create an inside function to check which values are inside the Monte Carlo simulation. And here I initialize the Monte Carlo simulation, and I'm running the example of pi. Essentially what I do is I'm trying to calculate the number of pi. I just run this with 100 samples. I can increase the number of samples as we did last week, right? So that's the example of the Monte Carlo simulation. Okay, to run this, as you can see, the only thing I have to do is to move this again inside my container and run it. Alright, so the moment I have my cluster, the only thing I have to do is to move my code inside, essentially if I have any data as well, and then I have to run my tasks. Alright, by now we're just running, let's say, computational intensive tasks, so we have everything in the code and we just go and run it. The data is actually data that I have in my code. For example, I give the number 100, or before I say the numbers are between -10 and 10, so I don't really open a file for this. Okay, so you can see here this took like 7.8 seconds and the pi is 3.36. That's fine. Okay, we say that if I go here and change the number of runs into 1000, probably this will take much more time. At the same time, it will be closer to the value of 3.14. A final example that I want to show you is the example of using some data. So we'll run a query. It's typical stuff. We have a JSON file, and as we do in Python, we always load the file in Python and we make it a data frame. We run some queries, find this, find that, select, okay? So what I will do, let me run this command. I will explain you what is happening here. I will just press an enter here. Let me clear maybe my screen. So Docker execute this container ID, okay? And what I will do, I will search here. I run this list command. The examples in the source main resources, right? There are some example data here. As you can see here, there is an example called people.json. There is an example called kv1.txt. So there are different examples here. I don't really need to create the data myself. I will just use some of these examples. Literally what I will do, I will just cut this file here, this one. Okay, so Docker execute the container ID is the one that I exported before. Cut the people.json. Okay, so I should be directed to this file here. Again, I use this in order to run a cut command inside my container. You can see this is a very small JSON file. What it has key name, value Michael, key name, value Andy, age, okay, name Justin, age 19. Okay, so we have 3 records here. But literally this is a small, let's say, JSON file. All right, I can actually transform it to a data frame and ask some questions here. The question that I will run, in my case, in this example 3 file, is the following. What I will do, I will build a simple SQL application where I will run this command. I want to select all the data from people where age is greater than 20. In my case, it should be only Andy. So I will run this query to my data. So what I do, I build a new Spark session. I make my configuration here, I create a new session, I read the files, so I read my json.file, okay. I create a data frame of this data using the people, alright, so I focus only on the people dataset, I call it people, and from these people I select those that have an age greater than 20. Now, it's not a straightforward task always to run SQL commands on top of data frames, but this is a way to demonstrate that with some basic knowledge of Spark, we might be able to run these kind of things, okay? While in Hadoop, you will see that it's quite hard to create these commands. Alright, so in my case, let's go and give it a go. So what I have to do, copy this file into the container in the temp, and let's go and run it, alright? So I will run a query to my data. Okay, so let's run this command. Let's see. Hopefully, what I will see is a small representation of my data that include those people with age greater than 20. Essentially what it will happen is the data frame, in our case is very small, it will break in 2 pieces in my 2 workers, and every worker will run the queries and the worker will give you back the results. Alright, what I do first, you can see here in my code, I have a data frame show that says show the data frame. So somewhere here I should see my data frame, the whole data frame, okay? You can see for Michael we don't have age. And then I have another command here that says show the data frame for the SQL data frame. So literally what I do, I create a new data frame and I save the result of my SQL query. And you can see here I have only data for Andy, okay? So this is the person that has age greater than 20. With this one, I will conclude my Apache Spark tutorial. We try some different things. Obviously, what you need to do now is to go and study more on how to write Python scripts, in our case, in order to connect to Apache Spark and parallelize your queries. That would be all, and I will see you again in our next class.